Okay, this is section 2.4 in your textbook, page 92. Equation for a circle. We'd like to read the little blurb. All right.
A license, well, the license?
Yeah, a license is not.
A license is not required for portable two-way radios. With a power of up to 2 watts, operating on General Mobile Radio Service, GMRS, frequencies in Canada. GMRS radios are similar to Family Radio Service, FRS radios, which are limited to 0.5 watts and use different frequencies. Some radios are hybrids that can operate on both the GMRS and the FRS frequencies.
Okay, it doesn't really mention the point of that. It actually gives you just a kind of description of different radio frequencies. But the idea is, as we know, when radio frequencies are broadcast, they broadcast out from a central point or a tower, and it moves out like a circle, right? So it has kind of a broadcasting distance that it goes, and that works as a radius of that circle. Okay, so then if we can calculate the equation of the circle, then we can understand how far that signal gets put out. Okay, so that's the idea. It's funny it didn't mention that. Page 94. So the first example we're going to do is we're just going to use our known formula for distance and use the center of the circle. So we're finding an equation for the circle with center 0, 0 and radius 4. Okay, so if we have, this is, 2.4. If we have a circle that's centered, it's not very good for me. Let's try that again. We have a circle that's centered on the radius, and we're given a point. We're not given the actual value, we're just told that it's x, y. This could be any point. Okay? So we're looking for the center we call the origin, or O, and it has a coordinate of 0, 0. So if we wanted to find the radius then, or the length of this line, we could use our formula for the length of a line. So OP, so the distance from this line to this line, is going to be our distance formula. Okay, so I've just subbed in the value then of the origin as one of my points. And my other point is a generic point labeled x, y. Alright, so I plug it into the formula for length of a line, so I have OP is equal to this. You should be familiar with that. I work it out and I have x2 squared plus y2 squared, square root. So I can replace those x2 and y2 with just x and y, because it's just a generic point, x and y. And then that's equal to the length of the line. But I'm also told in this question that I have a radius of 4. And the length of this line we know is actually the radius, right? Because any line from the perimeter of a circle to the center is the radius. So I know that OP is actually 4. So I can sub that in for the length of OP. And what I get is an equation for this circle. So an equation for the circle then, if I square both sides, so eliminate this square root, I'm going to square both sides. Okay, so that will give me 16 squared is equal to x1,
Sir, 16.
or sorry, Yeah, thank you. 16 is going to be equal to x squared plus y squared. So that's my equation of a circle, this particular circle. And the equation of any circle then would be our radius squared is equal to our generic point. So this is our equation of a circle centered on the origin. Equation of a circle centered on the origin. Okay, remember, only centered on the origin because I had to use those values of 0 and 0 to develop that equation. All right, so very quickly we're going to do an example here. This is example 2 on page 95. It says determine an equation and the radius of a circle that has its center at the origin and passes through the point a 6, -8. So it wants to know the equation and the radius. So I know my equation of any circle centered on the origin is equal to this. Okay, and I also have a point. It's given it to me, 6 and -8, so I can sub that in. R squared is going to be equal to 6 squared plus -8 squared. So we have 36 plus 64. So we have 100, and that's R squared. So R then is the square root of 100. That's how you find the radius of any circle centered on the origin. And the last point, which is B, it says, is the point B -5, 9 inside the circle? You would have to plug in that point -5 and 9 for the radius in the original equation. If the result is less than the radius, then it's inside the circle. If it's more than the radius, then it's not inside the circle. Okay, and you can see that explanation again at the end of page 95. Okay, and that's it for the lesson.